The National Electrical Code Section 440.12 requires each motor exceeding 1/8 horsepower to have a separate branch circuit. Overload protection is also required for each motor, typically provided by the motor controller or disconnecting means. The fan coil unit manufacturer's instructions must be followed for proper installation and operation. Each fan coil unit should have its own overload protection and disconnecting means. It's good practice to limit the number of fan coil units on a single circuit to minimize overloading and voltage drop risks. When determining the number of fan coil units on a circuit, consider the total connected load in amps, the circuit breaker or fuse rating, the wire size and length, and voltage drop allowances. For 460 volts, 3-phase fractional horsepower fan coil units, it's generally safe to put 2 or 3 units on a single circuit, assuming the total connected load doesn't exceed the circuit rating and the voltage drop is within acceptable limits. For larger fan coil units, specifically those greater than 1/2 horsepower, it's recommended to provide a separate circuit for each unit. Always consult with the equipment manufacturer and an experienced electrician to determine the optimal configuration for a specific application. Voltage drop in the branch circuit wiring is an important consideration when multiple fan coil units are connected to a single circuit. Excessive voltage drop can reduce motor performance and potentially cause overheating. The voltage drop should be calculated and should not exceed 5% for starting conditions and 3% for running conditions. Use appropriately sized circuit breakers or fuses for the total connected load. Install circuit breakers or fuses in a readily accessible location. Label each circuit and fan coil unit for easy identification. When assessing the feasibility of putting several fan coil units on one circuit, firstly calculate the total connected load. This involves summing the amperage draw of each fan coil unit that will be connected to the circuit. The nameplate on each unit will list its rated amperage. Secondly, determine the appropriate circuit breaker or fuse rating. This rating must be sufficient to handle the total connected load of all the fan coil units plus any additional loads on the circuit, while also providing overcurrent protection. The National Electrical Code provides guidelines for selecting the appropriate overcurrent protection device. Thirdly, evaluate the wire size and length. The wire size must be adequate to carry the total connected load without overheating or causing excessive voltage drop. Longer wire runs will result in a greater voltage drop. The National Electrical Code Table 310.15 provides ampacity ratings for various wire sizes and insulation types. Fourthly, calculate the voltage drop. Voltage drop is the reduction in voltage that occurs as electricity flows through a wire. Excessive voltage drop can impair the performance of electrical equipment, including fan coil units. The voltage drop should be calculated using a voltage drop calculator or the following formula. Voltage drop equals 2 times the length of the conductor in feet times the current in amps times the impedance of the conductor in ohms per 1,000 feet divided by 1,000. The calculated voltage drop should not exceed 5% for starting conditions and 3% for running conditions. Fifthly, consider the motor starting characteristics. Fan coil unit motors typically draw a higher current during startup than during normal operation. This inrush current can cause a voltage dip and potentially overload the circuit. The motor starting current should be considered when determining the number of fan coil units on a circuit. Sixthly, check for compliance with the National Electrical Code and local codes. The National Electrical Code and local codes provide specific requirements for electrical installations, including the number of motors allowed on a single circuit and the type of overcurrent protection required. Ensure that the installation complies with all applicable codes. Seventhly, consult with the equipment manufacturer. The fan coil unit manufacturer can provide specific recommendations for the installation and operation of their equipment, including the maximum number of units that can be connected to a single circuit. Eighthly, consult with a qualified electrician. A qualified electrician can assess the specific conditions of the installation and provide expert advice on the appropriate wiring and overcurrent protection for the fan coil units. Regarding voltage drop, the 3% voltage drop under normal operation and 5% during starting are maximums. Keeping voltage drop as low as possible is beneficial for equipment life and efficiency. The National Electrical Code provides guidance on voltage drop calculations in Informational Note Number 2 to Section 210.19a on. The formula mentioned earlier, voltage drop equals 2 times the length of the conductor in feet times the current in amps times the impedance of the conductor in ohms per 1000 feet divided by 1000, is a simplified version. More accurate calculations may be needed for longer runs or complex circuits, considering factors like power factor and conductor temperature. The ampacity of conductors must be carefully considered. The National Electrical Code Table 310.15 provides ampacity ratings based on conductor size, insulation type, and ambient temperature. These ampacity ratings are based on specific conditions, and correction factors must be applied if the actual conditions differ. For example, if the ambient temperature is higher than the table's reference temperature, the ampacity of the conductor must be reduced. Additionally, if multiple conductors are bundled together, the ampacity of each conductor must be derated. Overcurrent protection devices, such as circuit breakers and fuses, protect conductors from overloads and short circuits. The overcurrent protection device should be sized to protect the conductor while allowing for the motor starting current. The National Electrical Code Section 430 provides detailed requirements for motor circuit protection. When using fuses, it is important to select the correct type of fuse for the application. Time delay fuses are often used for motor circuits because they can withstand the high inrush current during motor starting without tripping. Non-time delay fuses may trip unnecessarily during motor starting. Circuit breakers also come in different types with varying trip characteristics. Inverse time circuit breakers are commonly used for motor circuits because they trip faster as the overload current increases. Instantaneous trip circuit breakers are designed to trip very quickly in response to a short circuit. Ground fault protection is another important safety consideration. Ground fault protection devices are designed to detect ground faults, which can occur when a current carrying conductor comes into contact with a grounded surface. Ground faults can be dangerous because they can cause electric shock and fires. The National Electrical Code requires ground fault protection for certain types of circuits. Arc fault circuit interrupters, or RFCs, are designed to detect arc faults, which are dangerous electrical arcs that can occur in damaged or deteriorated wiring. Arc faults can cause fires. The National Electrical Code requires RFCs for certain types of circuits, particularly in residential occupancies. Another aspect to consider is the disconnecting means for each fan coil unit. The National Electrical Code requires a disconnecting means within sight of and readily accessible from the equipment it serves. This disconnecting means allows for the equipment to be safely energized for maintenance or repair. The disconnecting means can be a circuit breaker, a switch, or a plug and receptacle. The disconnecting means must be rated for the voltage and current of the equipment it serves. Labeling of electrical equipment is essential for safety and ease of maintenance. The National Electrical Code requires that all electrical equipment be labeled with its voltage, current, and other relevant information. The label should be durable and easily readable. In addition to the requirements of the National Electrical Code, local codes and regulations may also apply to electrical installations. It is important to check with the local authorities to determine what codes and regulations are in effect. Regular inspection and maintenance of electrical equipment is essential for safety and reliability. Electrical equipment should be inspected periodically for signs of damage or deterioration. Any damaged or deteriorated equipment should be repaired or replaced promptly. Maintenance should be performed by qualified personnel. When working on electrical equipment, it is important to follow all safety precautions. Always to energize the equipment before working on it. Use appropriate personal protective equipment, such as gloves and safety glasses. Never work on electrical equipment when you're wet or tired. The specific type of fan coil unit also matters. For example, a fan coil unit with an electronically commutative motor, or ECM, may have different starting characteristics and energy consumption compared to a unit with a traditional induction motor. ECM motors are generally more energy efficient and have a softer start, which can reduce the inrush current. The control system for the fan coil units can also affect the circuit loading. If the units are controlled by a central building management system, the system may be able to stagger the starting of the units to reduce the peak demand in the circuit. The physical location of the fan coil units relative to the electrical panel can also impact the voltage drop. Units that are located further away from the panel will experience a greater voltage drop. Consider using larger conductors for longer runs to minimize voltage drop. The type of building construction can also affect the wiring methods used. For example, in some types of construction, it may be necessary to use metal conduit to protect the wiring. The use of metal conduit can affect the ampacity of the conductors, so it is important to consult the National Electrical Code tables to determine the appropriate ampacity. When adding fan coil units to an existing circuit, it is important to verify that the existing wiring and overcurrent protection are adequate to handle the additional load. It may be necessary to upgrade the wiring or overcurrent protection to accommodate the new units. Before making any changes to the electrical system, it is always best to consult with a qualified electrician. An electrician can assess the situation and provide recommendations that are safe and code compliant. Consider the long-term implications of the design. While it might be technically feasible to put several small fan coil units on one circuit, think about future maintenance or upgrades. If one circuit breaker trips, multiple units will be affected. Separating the units onto individual circuits provides better isolation and easier troubleshooting. If the church school building is likely to undergo renovations or expansions in the future, consider designing the electrical system with extra capacity to accommodate future needs. This can save time and money in the long run. Also, it is important to document all electrical work that is performed. This documentation should include a wiring diagram, a list of all the equipment that is connected to each circuit, and the ratings of the overcurrent protection devices. This documentation will be helpful for future maintenance and troubleshooting. Remember that electrical work can be dangerous. If you are not qualified to perform electrical work, it is best to leave it to a professional. Working with electricity can be fatal if not done properly. Always follow all safety precautions and consult with a qualified electrician if you have any questions. Keep in mind the specific application. A church school building may have specific requirements or considerations due to its occupancy and use. For example, emergency lighting and fire alarm systems may have specific requirements for circuit separation and reliability. Ensure that the electrical design takes these factors into account. Consider energy efficiency when selecting and installing fan coil units. Look for units that are Energy Star rated and that have efficient motors and controls. Proper installation and maintenance can also improve energy efficiency. Educate the building occupants about how to use the fan coil units efficiently. For example, encourage them to turn off the units when they are not needed and to avoid setting the thermostat too high or too low. By following these recommendations, you can ensure that the fan coil units are installed and operated safely and efficiently. This will provide a comfortable and reliable environment for the occupants of the church school building. Do not underestimate the importance of proper grounding. A properly grounded electrical system is essential for safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the overcurrent protection device and prevent electric shock. The National Electrical Code provides detailed requirements for grounding electrical systems. Ensure that the grounding system is properly installed and maintained. Consider the use of surge protection devices. Surge protection devices, or SPDs, protect electrical equipment from voltage surges which can be caused by lightning strikes or other electrical disturbances. Voltage surges can damage sensitive electronic equipment, such as the controls for the fan coil units. SPD should be installed at the main electrical panel and at any subpanels that serve sensitive equipment. When selecting SPD, it is important to choose devices that are rated for the voltage and current of the electrical system. The location in Central Florida is prone to lightning strikes, so surge protection is a wise investment. When working with 460-volt systems, the potential hazards are significantly higher than with low voltage systems like 120 volts or 208 volts. Extra care and precautions are necessary. Ensure all personnel working on or near the electrical equipment are properly trained and qualified to work with high voltage systems. Use appropriate personal protective equipment, including insulated gloves, safety glasses, and arc flash rated clothing. Follow lockout tied-out procedures to de-energize the equipment before working on it. Double check that the equipment is de-energized before starting any work. Maintain a safe working distance from exposed energized parts. Be aware of the potential for arc flash, which is a dangerous electrical explosion that can occur when there is a short circuit or other fault in the electrical system. Arc flash can cause serious burns and other injuries. Conduct an arc flash hazard analysis to determine the potential arc flash hazard at each piece of equipment. Label the equipment with the arc flash hazard information. Use appropriate arc flash protection when working on or near energized equipment. Be aware of the potential for electric shock, which can occur when a person comes into contact with an energized conductor. Electric shock can be fatal. Avoid contact with exposed energized parts. Use insulated tools and equipment. Never work on electrical equipment when you are wet or tired. Have a qualified person nearby who can provide assistance in case of an emergency. Regularly inspect the electrical equipment for signs of damage or deterioration. Replace any damaged or deteriorated equipment promptly. Keep the electrical equipment clean and free of debris. Maintain a clear and unobstructed path to the electrical equipment. Follow all applicable safety codes and regulations. By following these safety precautions, you can minimize the risk of injury or death when working with 460 volt systems.